Hello and welcome to the Science Club Daily. I am Ross Balch, and today I wanted to talk about some new research which used AI machine learning to discover new antibiotics. Now, it isn't exactly new that people would use AI to look for antibiotics. However, this is the first time it was used to actually find a molecule that doesn't really work like other molecules that we already know about. Now, of course, the reason that we need new antibiotics is that antibiotic resistance is currently becoming a much bigger and bigger problem in the world. As we run out of antibiotics that are useful, of course, the ones that we're saving for the ones that tend to be pan-resistant, that means resistant to almost all antibiotics, they're starting to run out. And of course, eventually we may get resistance to those as well. So it's actually really important that we actually manage to find some new antibiotics so that we don't go to essentially a pre-antibiotic era where a lot of people died from simple things like, a cut on the finger could have been fatal before we had antibiotics to help with the situation. So the cool thing is that this research actually has come out of the University of Pittsburgh in Pennsylvania. And these guys actually do quite a lot of AI type stuff, which is really cool. So AI has a lot of different meanings. And when we talk about neural networks, these are essentially like artificial intelligences that are modeled over the way our brains work. And in that, what you do is you feed them a lot of data. And by making these kind of networks and connections, they eventually can find patterns. And often they find patterns that humans can't possibly kind of come up with because of just how many different things you'd have to look at. Whereas obviously you can set these machines going with lots of parallel CPU cores or GPU cores, and that will help a lot. So they actually used a collection of 2,335 molecules, which we already knew that those molecules had some kind of antibacterial activity. And this included already like 300 approved antibiotics and 800 natural products from things like plants, animals, and microbial sources. And then the algorithm uses this data to essentially predict the actual molecular function. So this is basically what the molecule can do without actually knowing how any of the drugs work that you input. So basically what you do is you tell it, well, we know these drugs work, but you don't tell it how. And this is called like an unsupervised learning model, essentially. And then you train the model on all of this data, and then you use essentially molecules that you don't know the activity of. And in this case, they had 6,000 different molecules that were currently being investigated to see if they could work on various different human diseases. And they wanted to know specifically, could it work against E. coli? Now, the interesting thing is that they looked at all these results, and the researchers found about 100 candidates that they eventually went on to test. And out of that, 23 of them looked the most promising, and one of them, out of the 8 that actually did show antibiotic activity, they tested in mice. Now, the interesting thing is they actually called this halicin, the molecule, and that's named after Hal, the AI from 2001: A Space Odyssey, the classic film, of course. And the interesting thing is that this antibiotic works in a way that is quite different to a lot of others. Like, a really classic way that these enzymes work is they can block the way that proteins are made, because bacteria have slightly different protein-making mechanisms than humans. They also can disrupt things like the cell wall. Human cells and most mammal cells, they just have what's called a lipid bilayer, which is like basically a layer of fat that kind of protects the cell. Whereas all bacteria, they actually depend on a stronger cell wall on the outside of that to keep them from getting attacked by the environment and the immune system and things like that. The interesting thing of this one is that the way it actually works is it disrupts the flow of protons across the cell membrane, which is really interesting because that process is really important. It's really important in humans too. But if you can't transport proteins across the membrane, essentially you don't actually have a way of making energy in the cell. And when we tested it in mice, there was actually very little toxicity. And this drug had previously been trialled looking into diabetes. So it's a really interesting look into how things like machine learning can find these patterns that were just never available before. And I'm really interested in machine learning myself, and I think that if you have clean data, you can get really interesting things out. Some of the problems with previous machine learning efforts actually have been that some of the data in
wasn't necessarily 100% clean, and therefore what happened is the results that come out don't really reflect nature, but if you have a nice and really clean input, you can get amazing results out based on patterns that humans could never see. And I think we're going to see this kind of like machine learning and this like application to all sorts of things, because you don't just have to look for drugs, you can look for all sorts of things, like say you have a whole bunch of data on planetary readings, and you want to find, well, what could a habitable planet look like? And if you already know of some, say, that have those characteristics, you can feed all of this data in to really quickly identify habitable planets. And it's kind of endless, really. Like, you can do all sorts of things with this, as long as you have a database of things that you know the properties of, and you can give it to a machine learning algorithm, and then have the algorithm do what's called inferencing. So the training is where you give it the data, inferencing is where you give it raw data and have it classify it. And so there could be other drugs, a lot of different scientific approaches, even, like molecules or chemistry that could work very well, based on chemical structures and things like that. So it's going to be really exciting to see how this evolves, especially when a lot of big companies like Google, Amazon, Facebook, they're all really heavily investing in this. And I think we're going to see a lot more stories like this in the